All right, so just to continue on the end of 1.1, the last part of this section is regarding variables and constants. So there's a title for us right there. And within this category, we want to just define a few things. A literal number. A literal number is when a letter represents a number. And so a variable then is literal numbers that can vary. Literal numbers that can vary. And that means there isn't just one value that is subbed in for the literal number, because some literal numbers are fixed and some are variable. And so a literal number, or any letter that can vary, is a variable. And if it is a fixed value, then it is called a constant. So a constant is a literal number that are held fixed. So literal numbers that are held fixed. Oops. Okay, so we're going to see that sometimes we have a letter in a formula that can be a variable, so that input of that letter with a number can change or can vary, or it's a constant, it's a fixed value. All right, so now at the end of this section, I always suggest some homework. So I'm going to say right now, homework, if you want to practice some of this stuff, is from exercises 1.1, and I suggest that you do numbers 7, 9, 11, 13, 15, and 17. These are odd numbers. The answers are in the back of the book, so you can check how you're doing. And from this section 1.1, this would be the area where I'd like you to focus and be able to do on your own. All right, that's the end of this section 1.1. I'm going to continue in this video beginning in 1.2. Okay, so in 1.2 we're going to talk about the fundamental operations of algebra, and these are some of the names of them. So the commutative law of addition, and this basically states that A plus B equals B plus A. And that might seem quite simple and obvious, but basically this tells us that for addition, we can add in either order and we still achieve the same result. Okay, so you can even look at an example numerically and see that something like 5 plus 3 is equal to 3 plus 5. Addition works in either order. Okay, there's also the associative law of addition. That if we look at it in formula looks like this. A plus and the quantity B plus C is equal to the quantity A plus B plus C. So if you know from BEDMAS, the order of operations in this tells us to do the brackets first, right? So we would find the sum of these two, and to that sum we add A. Whereas in this order, we find the sum of A plus B, and to that sum we add C. And the result will be equal no matter what order we do it in. So I can throw in some numbers as well and do 2 plus 3 plus 4. And that's the same as 2 plus 3 plus 4. All right, this one becomes 2 plus 7. This one becomes 5 plus 4, 9 equals 9. Yes, okay. So that's just a numerical example to show that that works. Another fundamental operation of algebra is the commutative law of multiplication. And that states that A times B equals B times A. And this is helpful to know when you're working with formulas and doing rearrangements and so on. It doesn't matter what order we multiply in, that 3 times 6 is equal to 6 times 3. We get the same result either way. The associative law of multiplication is a very similar one, but it's more about the grouping, so that A multiplied by the product B times C is equal to the product AB multiplied by C. And really, we just have, in both cases, A times B times C. Okay? The last one is this distributive law. Let's do it in a different color to make it stand out a little bit. So the distributive law states that when we have a value multiplied by the sum of two others, or of any two, that what we should do is multiply A times B and add to that the product of A times C. Okay, so distribution is used to eliminate brackets, and this might be useful, for instance, if we cannot perform the sum inside the brackets, like when these are not like terms, then we should eliminate the brackets by using the distributive law, and we are going to see this happen an awful lot. All right, next we're going to look at operations on positive and negative numbers. And so the first example is about adding numbers of the same sign. So for example, adding adding 5, that's a positive 5, plus a positive 2. These two numbers have the same sign. They are both positive. The result will be positive 7. Adding numbers of the same sign where they are both negative, maybe negative 5 plus negative 2. If they are being added and they are both the same sign, both negative, the result will be negative 7. Now, one way I like to look at this one, because this one is a little, you're probably a little less familiar with this would much more used to. So if this is my number line, and I begin at negative 5, negative 6, negative 7. Okay, let's get another color. And if we begin at negative 5, and we add a positive. Adding a positive takes us to the right. But we are adding a negative, so we should go the other direction. And adding a negative, we want to begin at negative 5 and add negative 2. So we're adding 1, 2, add negative 2. And we end up at negative 7. All right, so it's always helpful to picture the number line. When you add a positive, all right, this is adding a positive, and this is adding a negative. So adding a positive, we go right. Adding a negative, we go left. Let's look at our next example here. Adding numbers of different signs. So for example, 8 plus, that's a positive. So we better add to that a negative, negative 2. Well, again, we are adding a negative, which means we should go left on the number line from positive 8. So there's my number line. If I have my 8 sitting here, and we go 2 spaces left, the answer is 6, because that's where we end up. Another thing that some people do is you can interchange the signs here. So this positive 8 can become subtract positive 2. So that is just 8 subtract 2, which is 6. So that's another way to look at that one as well. Changing the sign to do the negative first, negative 2 plus positive 8. Okay, this was still adding numbers with different signs. If I sit at negative 2 and I add 8, adding a positive means go right on the number line. So there's my number line. Negative 2 is here. All right, so sitting at negative 2, I move 8 places to the right. And I end up at 6. Okay, so there are many different ways to visualize it or to figure it out, but just remember you're at a starting point. If you're adding a positive, you go right. If you're adding a negative, you go left. That's addition. Now, I will look at subtraction, okay? Subtracting positive and negative numbers. Well, you've been doing subtraction for a long time. 4 subtract 1. Subtracting a positive. Think about the number line. Which way do you go? You go left. So there's my positive 4. If I subtract 1, okay, this is subtracting a positive. We go to the left. So it should be true that subtracting a negative, we go the other way, subtracting a negative. And that turns out to be the same thing as adding a positive. Okay, so let's look at an example like that one. 6 subtract negative 1. Where are we going to end up? Well, subtracting a positive, I should go left. So subtracting a negative, I should go right. I am becoming greater. Therefore, the answer is 7. Right? So if we're at 6 and we move 1 place this way, subtracting a negative, the answer is 7. What a lot of people do, I think this is a common one, is when they see these two negatives together, they go like this and make it positive. So this becomes 6 plus 1 is 7. Okay, so I'm trying to give you some tools to use for working with positive and negative numbers in terms of addition and subtraction. And please, if this gives you some trouble, do some practice. Work on using your calculator too. If you are using a calculator, there's probably a plus minus key on there. Don't use the subtraction key to make a number negative. That doesn't work. Change the sign of the number with the plus minus key. All right, so I'm going to stop here. This is going to be the end of the part 2 video, and I will have a part 3 coming up.